3.4, Transforming Functions, Part 2. Okay, so what's a little bit different about this example is that when we look at our equation y minus k equals f a, I missed the a, f b x minus h, the b is actually in front, it has been taken out of the x and the h. So in this example, because it is not in brackets and it just says 3x plus 3, it's not quite as simplified as it needs to be. So what we're going to do is we're going to take out a 3, and this becomes x plus 1. Now it is into this form of the equation that we have. So our a value is -1, our b value is 3, our h value is 2, and our k value is -1. And the transformations that we have happening is we have a reflection, and because the reflection is changing our y values because it's an a value, that means that it is a reflection in the x-axis. We have a horizontal compression, a horizontal translation, and a vertical translation. Alright, let's start with doing domain and range here. So x is going to be greater than or equal to 0. And same with our y. Okay, let's transform our function. So we have x and y, and then we have, let's transform this. So we're going to have x over 3 plus 2 and negative y minus 1. Okay, that's not right because I put these in the wrong spots. So my k value is 2 and my h value is -1. I couldn't figure out what I did wrong. I just wrote them in the wrong spots. Okay, so it's going to be x over 3 minus 1 and negative y plus 2. There we go, we're good now. Okay, so our points are, we can go with 0 and 0, we can go with 1 and 1, and we can go with 4 and 2. And I know I'm going to be able to use all those points because this is a square root function, a radical function. Okay, so I want you to pause the video and I want you to transform all of the x and the y points. So what you should have gotten was -1 and 2. Then you should have gotten -0.666666 repeating and 1, or you could have had it as -2/3 and 1, and 0.3 repeating, or 1/3 and 0. So we will plot these new points. So -1 and 2, -0.6 and 1, and 0.3 and 0. So it looks like that, and our graph would go like that. So that is our new function. Our domain is going to be greater than or equal to -1. And our range is going to be less than or equal to 2. So this is our max point for both of them, or min point. Alright, let's do another one. So same graph, square root function, and we're going to do the following. So same thing here. We're going to take out a -1 because we need it to be in the right form. So now my function looks like this. So my A value is 2. My B value is -1. My H value is 3. My K value is -1. Because B is negative, that means our X values will be flipping, so we're going to have a reflection in the Y axis. And domain and range is the same as last time, greater than 0 for both. Okay, let's make our new point. So we have x and y, and we'll use 0, 0, 1, 1, 4, 2. And now our x value is going to be negative x over 1, which is just negative x, plus 3. And our y value is going to be 2y subtract 1. So I want you to pause the video and I want you to find all the new points. So you should be getting 3 and -1, 2 and 1, and -1 and 3. So again, plugging those values in for x and for y to solve for our new transformed points. So we have a point at 3 and -1, we have a point at 2 and 1, and we have a point at -1 and 3. So our graph looks like that. So our new domain is x needs to be less than or equal to 3. And our range has to be greater than or equal to -1. So that is combining some points. Now we're going to work backwards. We want to take a graph. Nope, just kidding. We're going to make an equation. Alright, the graph of y equals the square root of x is vertically compressed by a factor of 1/5. It is horizontally compressed by a factor of 1/3. And it is reflected in the y-axis, translated 3 to the right and 2 units down. So let's go through each of these things. So first off, if it is compressed by a factor of 1/5 vertically, that is our A value, so our A is 1/5. If it is horizontally compressed by a factor of 1/3, that means our B value is the reciprocal, which is 3. If it is reflected on the y-axis, that means our x values are changing, which means our B value needs to be negative because B affects our x values. It is translated 3 to the right, which makes our H positive 3, and 2 units down makes our K -2. So we're going to start with y equals the square root of x. If you need to write it in as y minus k equals a square root of b x minus h, you can start like that. And then we will have y minus 3 equals 1/5 -3 x minus 3. Oops, I put the wrong one over here. Y plus 2. So this is our equation. If you want to go one step further and get rid of this brackets, you also could say y plus 2 equals 1/5 -3x plus 9. That would be simplified as well. But I am happy with both. So if you're having trouble with this step, come see me, we'll fix that. Okay, now we're going to work backwards. We're going to take a graph and we're going to find an equation from it. So what you need to be able to do this is you need to have 2 points and to show how those 2 points have changed. So we have point A, which is at 1 and 1, and it changes to point A prime, which is -1 and 4. We also have point B, which is 2 and 0.5, and it changes to B prime, which is 1 and 3. So what we have to do is we have to figure out our A and our B values first, so how much they've been stretched or compressed. So the way that we do that is we check to see how these 2 points have been changed in proportion to one another. So we can't just see where they've moved to, because that's just a translation, but we can compare how they have changed between the space between A and B. So what we're going to do is we're going to see the change in our horizontal and our vertical between A and B. So what we do is we just subtract them. So we're going to go from A to B horizontally. So from A to B horizontally, we go from 1, that's from here to here. So 1 minus 2. And we're going to do the absolute value of it because we're not going to worry about reflections or anything else. So the distance horizontally between A and B is 1. Now we're going to do A prime to B prime. So the distance from A prime to B prime is negative 1 to 1, which is 2. So what this means is that we know that if we take an x value and divide it by b, it becomes x prime. We did this in a previous lesson. So if our original horizontal distance was 1, and now it is 2, we can flip those, and we can find that b is changed by 1/2. And it's doubled. If we think about it, it is doubled, so that means that our b value is 1/2. Okay, let's do the same exact thing for vertical. So from A to B, we're going to do our y values. So we have 1 minus 0.5, which is 0.5. So in the original graph, they changed vertically by 1/2. In our transformed graph, it goes from 4 to 3, which is 1. So this one also has doubled. If you think about it like that, it's doubled. So if I go a times y and it becomes a prime, it was originally 1/2 and it became 1. Divide by 0.5 and y is 2. And I have that all funny. These are the wrong letters. It should say a times y equals y prime. There we go. And that should be an a. So a is 2. Now what we need to do is we need to figure out how much it's been moved left and right. So now what we're going to do is we're just going to look from point A to A. Or A to A prime, I guess. So we know that x over b plus h and ay plus k is our new point. We also know that so x over b plus h equals x prime, and we know that ay plus k equals y prime. And we now know what a and b are. We also can figure out what x and x prime are and y prime are because we have this point a to a prime. So we're going to just use the a values. So we're going to say x is equal to 1, y is equal to 1, and then x prime is equal to negative 1, and y prime is equal to 4. So we're just going to plug these now into our these equations right here. I just wanted a little bit more space. So we're going to say x over b plus h equals x prime. So we know x is equal to 1. We know b is equal to 1/2. We do not know what h is, but we do know x prime is negative 1. So we have 1 divided by 1/2, which is 2. So we have 2 plus h equals negative 1. Subtract 2, we get h to equal negative 3. So we found our h value to equal negative 3. We'll do the same thing. ay plus k equals y prime. And we have a is 2, y is 1. We don't know k, but we know y prime is 4. So we have 2 plus k equals 4. Subtract 2, k is equal to 2. So now we have all of our values. We're going to plug it into our function. So y minus k, we don't know the equation of the graph. So we'll just plug it into this. So we have y minus k, so y minus 2 equals a, which is 2, f negative 0.5, or that's just a 0.5. I don't know where all of these went. 0.5 x minus negative 3, so plus 3. So there is our equation for this function. Let's do another example of this because I'm sure you need one. So let's figure out our A points, so 0 and 8. And our B point is 2 and negative 8. We are moving to A prime, which is negative 2 and 0, and B prime, which is 0 and negative 8. So let's start by figuring out our horizontal change. So we're going to go A to B first. So we have 0 minus 2, which is 2. And then we're going to have A prime to B prime, which is negative 2 minus 0, which is 2. So it doesn't change, so our B value is going to be 1. Now we're going to do our vertical. So we're going to go from A to B first. So we have 8 minus negative 8, which is 16. We're going to go A prime to B prime, which is 0 minus negative 8, which is 8. So we have A times y equals y prime. It begins as an 8 or a 16, and it becomes an 8. So it's changing by a half. So A is equal to 0.5. Now we're going to figure out our translations. So we know a point goes from x over b plus h to get to x prime. And we know a point goes from a times y plus k to get to y prime. We're going to use the points a to a. So x1 is equal to 0, y1, x, there's no x1, I'm thinking of slope. X is equal to 0, y is equal to 8, x prime is equal to negative 2, y prime is equal to 0. So we'll do x over b first, so 0 over 1 plus h equals negative 2. So we have 0 plus h, so h equals negative 2. A we have is 0.5, our y value is 8, plus k equals our y prime, which is 0. So we have half of 8, which is 4, plus k equals 0, so k is equal to negative 4. So now we have all of our values. So we have y minus k equals a f b x minus h. So we have y subtract negative 4, so plus 4 equals a, which is 0.5. F, we don't have a b value, so don't worry about it. X minus negative 2, so plus 2. And there is our equation. And that is the end of 3.4. Right, bye.